So, without further ado, it's my pleasure to introduce the next talk, 101 Things You Can Do with a Laser. Now, this year is the laser's 50th birthday party. It's its 50th birthday. To introduce us to the many diverse uses of lasers, it's my pleasure to introduce Dr. Evil, also known as Dr. Bill O'Neill, from the Centre of Industrial Photonics. Without further ado, Dr. Evil.
We're not having a fire drill. I've got a laser down here, for goodness sake. So we might not have a fire drill. The aim is not to have a fire drill. I appreciate it. Thank you very much for coming. If my name was Dr. Goody Two-Shoes, you'd be half full, this auditorium, I'm sure. But I do appreciate the attendance. 50 years ago, some pretty clever spectroscopists came up with an idea about how to make a new form of light. It was called the laser. And 50 years ago, we had no idea what to do with it. And 50 years ago, they still pumped lots of money and lots of research into this idea, and it's become the most important piece of technology mankind has ever invented. Then I would say that, wouldn't I? So I'm going to sort of waltz you through some specific benefits of lasers, not necessarily the ones that you might think you would like to use them for, because they're all very boring, they're all very clever, but let's face it, they're pretty demanding pieces of technology. They're pretty useful for evil geniuses, which is where I come in. So, let's march on. But before I do, of course, I need to just double-check one thing, that my remote control works. Made by Apple, honest to goodness. License agreement. Everybody in this room must read the following very quickly, agree to it. If you don't agree to it, leave. Good, thank you very much. Particularly the point which says, you agree to be bound by the terms of this agreement of Dr. Evil by not using any of the ideas. If you do not agree, copy or use the ideas, you may return to your home and spend the rest of the day in your room without any tea or anything, not even a bedtime story, if applicable. Thank you. I appreciate you agreeing to my agreement. So, what's so special about lasers? Well, as was said at the introduction, they're amazing things. They produce coherent light. Now, coherence means the same color. And those lasers in that picture, red and green, produce the very, very narrow light color spectrum. And so that's quite useful, because it means we can do interesting things with them. We can focus them, and we can apply them to make things happen, and we can do all sorts of fancy things in the chemistry laboratory. They produce very powerful beams, as we'll see later on. That's my interest. I'm not really interested in these colorful beams, these beautiful beams that we can have and shine around. And I've got some examples of some very beautiful, colorful beams. This is the next generation warning flare. Don't buy a flare, it goes up in the air. This is oh, help me, I've lost my boat or something like that. You can buy these, and this is essentially what we use them for. No more fireworks. It's so 19th century. This is a laser flare rescue device. Costs you about $200, and you can focus it and scare pigeons off your trees and things like that. So, there we go. A useful form of laser if you have pigeons in your trees. Right, they travel in straight lines. Not this one, because I've just made it travel in divergent lines. I've made it spread out, but you can focus them and you can spread them out. You can do all sorts of things. And that's the power of lasers, is being able to be focused and controlled. I must be careful not to blind the audience. Must be careful not to blind the audience. Okay, they travel in straight lines. Yes, sort of. Sort of. Light bends, Einstein said that, and we kind of know it. Read a physics book or something, they'll tell you. Okay, they can heat material, really cool stuff. We can heat material. We can take material from room temperature to about 1 million degrees in a nanosecond. That's pretty cool. Come and see it in the labs. It's very cool. We can cool atoms, which is even cooler. We can hold atoms in the center of a beam and just keep them still, so still, that they cool down. And that's atom trapping and keeping the atoms cool. And we can make the coldest point in space and time with a powerful laser beam. Go to the National Physical Labs in London, where they do all these measurements and do these fantastic things with lasers, and you'll see these coldest points in space and time made by laser beams. We can do things with chemistry. Lasers can ignite chemical reactions. They can stop chemical reactions. They can speed chemical reactions up. All very useful if you're a chemist. Not very useful if you're Dr. Evil. Okay, I guess we have to sort of play some lip service to the fact that they're very good for disco dancing. you know, more enjoyable discos or something. Smoke boy, come, come. Hurry up, hurry up. Right, and then what does it mean? Well, I know you're not all evil, so goggles on, goggles on. Don't blind the audience, don't blind the audience. Right, let's have a look. So.
Come on and try. Now's the time for your dreams.
So
Do
good.
what you want to do. You got to live in your life.
Please never rely upon dancing laser beams.
Do what you want to do. 'Cause you're free.
Right.
Do what you want.
First disaster of a lecture. Okay, stop. Thanks, smoke boy off. Oh no, stay here, stay here. So, blow some smoke.
Do what you want to do.
What's happening to my laser? I cannot believe it. Okay, blow some smoke. Show this. Blow some smoke. Not very good at all, really. Thank you, smoke boy. Okay. I think someone's played with my dancing laser beams. I'm not happy about that at all. Okay, on we go. Well, so what else can they do? You have to do useful things with lasers, otherwise they wouldn't get built. We can do things like weld cars. All your cars are welded with lasers. You can print on paper. You've got laser printers in your bedrooms. You can do things like play music and movies and DVDs and Game Boys and all that kind of stuff, I think. I'm not sure. You go shopping. Lasers are there to add up your shopping list. You don't have to do hard maths anymore. You just turn up and push it through the trolley. No more hard maths. What's happened to hard maths? Saves lives. Welding, pacemakers, making tiniest things that could be pushed through blood vessels and fix the heart and all sorts of other things. Saves lives. Help you cut straight. I love these. I want a pair of these. Laser-guided scissors. Have you seen these before? These are real. Don't laugh at me. These are real. Now, what would be really clever is if the laser cut the paper. Why do you want a piece of metal doing it? Come on, get real. Correct your vision. Mommy, where are you, Mommy? Lasers are really good at correcting vision. Most of the people who actually, it's a very good process, but some of the people who do the process wear glasses. Why is that? Better surgery. Surgeons with laser knives, better than metal knives. And there's a reason for that, because laser-cut tissue actually heals quicker. And it can be a much faster recovery rate. So it saves the hospital money, kicks you out early, so you haven't got to hang there staying in the bed all day, getting fed by nurses. So there are lots of other helpful things you can do with lasers. Very, very interesting, I'm sure. There are lots of books on it. Go and read some if you want to get any more information. My real interest, of course, is to see other things we can do with lasers. And being who I am, I tend to get lots of questions. It's not, oh, can you weld cars, Dr. Evil? Yes. Can you drill holes, Dr. Evil? Yes, of course I can. Can you mark my iPod, Dr. Evil? Yes, of course, of course. I don't get asked those questions at all. The question I get asked the most is, Dr. Evil, can you blow things up like they do in the movies? Can you blow things up with your lasers, Dr. Evil? God, who do they think I am? Of course we can. But it started me thinking, does it actually mean that all the things that you know about high-power lasers, because most of you will never come across them before, it's true, because of the movies? I thought, that's an interesting question. I have a new career. So I started making some lasers. High-power lasers. Lasers like we have in the movies. And there are very important people like Star Trek. Now, you might be a Star Trek buff or a Star Wars buff or something like that. I'm a Trekkie because that's real science. So I made one of these. This is the most powerful Mark I phaser in the universe. This is a sufficiently very high-powered 532 nanometer, 100 and something milliwatt, don't tell health and safety, laser gun thing. Has multiple settings. And I'm going to put it on, well, I'm not sure, Smoke Boy, would you like to come here? Goggles on, come on. Goodness gracious, what, 9 minutes in, 40-minute lecture. Thank you. Right, he's safe. I'm safe. Where are your goggles? Tough. You were warned. License agreement. Bottom line. Wear goggles at all times in Dr. Evil's lectures. Right. Ready? Smoke in space while point beam, yeah? He's very good, normally. He's an incredibly good mathematician, but not very sensible. Right. Ready? Let's hope this thing works. In sabotage, I think. Okay. Here we go. I'm going to show you. This was designed, actually, shan't be a moment. This was designed. Oh, sorry. This was designed to kill flies. In my jungle lair, I get constantly attacked by mosquitoes. Constantly. Nothing better than sitting down in your room. And it works. But I can't show you the video because people will object. Oh, you can't do that to mosquitoes. So I won't. I'll just show you what I do to balloons instead. Inanimate objects. But very, very, very scary if you have a balloon phobia. Okay, we ready? I'm going to fire over here. You blow smoke over here, okay? And you'll see the power of this laser. Then you turn stop. If you were a fly, you'd be really scared. If you were a fly, you'd be dead by now. But actually, if you're a balloon, you would survive, because clearly I can't throw high-powered beams around lecture theatres which can pop balloons. Can I? Thank you, Smoke Boy. Did you blow smoke, by the way? Oh. Try again. Very, very powerful beam. Keep blowing, keep blowing. Very powerful beam. If you were a mosquito, no chance at all. You just have to be a very good aim. Thank you, Smoke Boy. Thank you. Okay. So that's what I did. Started off with very small lasers. This is my lab somewhere up in, secret part of Cambridge.
Which is considerable.
First movie you've ever seen about lasers.
I think you've made your point, Goldfinger. Thank you for the demonstration.
Oh no, I'm scared. What happened next? Oh, I've got a... Oh, Mr. Goldfinger, I think I know something you don't. Really, how convenient. Anyway, he didn't get zapped by the laser, of course, but what would have happened had he? Volunteer, please? Joke. So, is this possible? Is this just fairy tale? It's a red beam. Look, I have a red beam. A really bright red beam. Look, it's very bright. Can you see smoke? Smoke boy? No, stay. Can you see smoke? No, Mr. Bond, yeah, sir. Of course not. Red beams aren't very powerful. Visible beams generally aren't very powerful. It didn't pop my balloons at all. Visible beams are not powerful. So what about this movie stuff? Well, I have a very, very extensive laboratory. I have an incredible wealth. I have enough money to do all sorts of things with my beams, and so I decided to reenact all of the James Bond moments to see whether they were actually very true. Hooray! This is James Bond. Oh no! Help! Oh no! This is a real laser, a really powerful laser. You can't, it's invisible. You can't see invisible lasers, can you? Who said yes? Get out. Next film, Moonraker, sky lasers, satellite lasers. Was it true? 1979, only 20-odd years after the laser was invented. The movie guys still thought, they're so cool, we're going to have them in our film, aren't we? Whether it was true or not, I hate that. Space laser. Oh no, nasty submarine comes along and says, so the light has to go through the water, of course. It has to heat up the ship so much that it explodes. Is that possible? Have you tried heating stuff underwater? No, you haven't. Well, you might do with a, I don't know. Well, how would you heat stuff underwater? A kettle. Not very useful. What about the real submarine test? The real example of taking this forward? Ooh, secret submarine. Don't tell anybody. But don't laugh at my submarine. This is perfectly acceptable. Okay, it's going underwater. This is a beam that will travel through the water. That's very powerful enough to blast metal, and yet this is, okay, a nearly plastic submarine, a carbon fiber composite submarine, and we're seeing not very much happening. We're seeing some interesting physics. We can see melting and bubble formation. We're actually evaporating the polymer. It's blowing bubbles. It's degassing. So this laser is capable of doing it. But it didn't think it until you do that. That was a very powerful laser firing down onto the turret. Everyone's running around. There's no one inside, by the way, of course. Everyone's running around. Burn. C'est possible. Right. Another Moonraker clip. This time it's, oh, another satellite will go and fly something in the air and blow up missiles on the ground. Something explosive. Heat beam, a red heat beam. Now, the really interesting thing about the physics of that problem is that actually we need a beam that will deliver thermal energy, infrared energy, the kind of stuff that you can feel off a fire or a hot cup of tea or a kettle. Don't touch kettles, especially if they're hot. And these are really important. This is an infrared laser beam. This is a beam which produces invisible light. And all of the powerful lasers that we have today pretty much are invisible. Now, I can get some more power with this kind of technology, but it costs an awful lot of money to deliver a very, very powerful version of this device. So we don't. And actually, if we had the same power device as this, equivalent to our very, very powerful lasers, you couldn't look at it. It would be so bright, you would not be able to look at it. So it's just as well we can't see. Now, I didn't have a collection of intercontinental ballistic missiles in my laboratory. Surprise, surprise. They're coming next week. I have a jet aeroplane, which I bought from the Ministry of Defense for some tests. And I'd like to show you the example of a space laser, a real space laser, firing down and doing stuff with things on the ground, moving and stationary. Space laser, fire now, please. Okay, this is a full-size metal aircraft with petrol in the wings and all the rest of it. And it was zapped by very, very powerful ballistic laser. Even if it flies, we can shoot it down. And you might think, I don't believe you, Dr. Evil. Well, go and ask Boeing if you can buy their Laser Avenger machine, bought out in February 2009, at a cost of about £10.5 million, and it will do exactly that. Bang, fire airplanes out of the sky. And that's true. Boeing Laser Avenger. All of you have got websites. Web links, sorry. So we can see that actually these movie guys weren't so wrong. They just got the type of laser wrong. Another very famous example of James Bond in the Living Daylights, or the Living Daylights, or I can't believe the Living Daylights, or something like that, 1987. This is when James Bond got boring, I thought. When the 80s were pretty dull, weird hair, bad clothes.